the following statement going to be true? That for all integers a, that a divides 0. Well, let's think of some examples, right? Let's take a positive integer a. For example, 1. Does 1 divide 0? Well, what does this notation mean? This means 0 can be written as a multiple of 1, or it can be written as 1 multiplied by k, where k here must be some sort of integer. And the answer is, well, yeah, k here just has to equal 0, right? 0 times 1 is going to be 0, so yes, 0 is divisible by 1. Next, we want to ask, well, what about 2? Does 2 divide 0? Well, it's going to be a very similar problem as here. It's going to mean, well, 0 is a multiple of 2, and that's true because 2 can be written as 2 times an integer, where the integer x here must equal 0. 0 times 2 is going to be 0. So it looks like we can kind of see the pattern with positive integers. What about negative integers, right? Well, let's take, for example, negative 1. Does negative 1 divide 0? Well, let's write that out. 0 must then be a multiple of negative 1, which means 0 can be written as negative 1 times m, where m here must, in fact, be an integer. And in this case, it must also be 0, like the other 3 examples. Finally, let's try negative 10, or no, let's do 101. Does that divide 0? Well, that means 0 can be written as a multiple of negative 101 times n, where n here must be an integer. And of course, in this case, n has to be 0, because 0 times negative 101 is going to be 0. What do we notice here? Well, we can use the fact that 0 times anything is going to be 0, so it's looking like this is true. But let's remember, all integers includes, of course, let me erase some space real quick. Now, of course, when we're looking at all integers, it includes the integers 1, 2, 3, 4, and so on and so forth, the natural numbers. It includes negative 1, negative 2, negative 3, negative 4, and so on and so forth. But it also includes 0. So we have to make sure that we've seen it probably works for positives, probably works for negatives. We should check that it probably works for 0. Well, let's check that. Does 0 divide 0? And the answer is surprisingly yes, or unsurprisingly yes. Because 0 on the right-hand side, I'll note this as 0, 2, and 0, 1. 0, 2 can be written as a multiple of 0, 1 times k, where k here can literally be anything. It could be equal to 1, equal to 2, equal to negative 1, equal to negative 2. It could also equal to 0. 0 times 0 is still going to give us 0, right? Any integer times 0 is going to be 0. So it's looking like this statement is in fact true. In fact, something you should note with this example, this very unique case with divisibility, is that this is probably the only time, or one of the very few times, you don't have to say that what's on the left-hand side must be an integer, but it cannot be 0. So let's quickly write down this proof so you know what I'm talking about. This is a for all proof, and how do we write all of our for all proofs? We start with the word let. What do we let? We let some integer be a. Then we say, then a divides 0 would mean 0 is a multiple of a times k. Now in this case, it's obviously going to be true, but what do we have to do? Well, to verify that this is true, because the only condition here, well, we have to first, we've introduced a, we now have to introduce k, where k is going to also be an integer. Okay, how do we verify this? We've supposed what we want to prove, right? We've supposed not what we want to prove, sorry, that's a cardinal sin. You don't want to suppose what you want to prove. We've supposed what we are starting with, and we want to get to what we want to prove. So what do we have to show? Well, we have to show that because a is anything, it must be true that k can also be anything. Well, let's have a look at this. We can then say, therefore, k is going to equal to 0 over a, which is absolutely valid. That's true. 0 over anything is a valid mathematical operation, which means k can be 0. And that's true. In all of the examples I've given, k can in fact be 0. There was no case where k could not have been equal to 0. So it looks like we have to clarify, since 0 is an integer, then a is in fact divisible by 0. So what did I mention earlier? Note we do not have to say what we've done in all of our other divisibility proofs, that what's on the left-hand side, a, cannot be 0, because we showed that 0 does in fact divide 0 in this case. And the second thing to note is, this is one of the few times you have to show that for this to be true, it must be that 0 can be written as a times an integer k, and you have to verify that k must be an integer. And in this case, we showed that if you let k be 0 in all cases for a, whether a is 1, 2, 3, 0, -1, -2, -3, regardless of what you let a be, if k is always equal to 0, then it's always going to be, it's always going to show that a divides 0. So there we go. We have now proven that this statement is in fact true.